Okay, good afternoon, good evening, good morning, depending on where you're logging in from. I'm Dr. Reggie Taylor, and I'm from the Office of Research and Doctoral Services here at Walden University. And this evening, I am going to be facilitating this binomial logistics regression session. Now, some of you may be familiar with the term binary logistics regression, the same thing, okay? So no confusion there. Binomial, binary logistics regression, sometimes it's just even called logistic regression. All the same, okay? So if anyone has attended this session or any of the sessions that I've done in the past couple of weeks, you'll notice that I start out with the first learning outcome, which is very broad and basic, but it's just to ease anxiety. There's no way that we could cover hierarchical linear regression in an hour, in 45 minutes, in 30 minutes, or anything like that. And I'm sure you can understand that. As I've mentioned, I've taken courses 16 weeks long just on specific tests. And so it's no way, but you're going to get the basic overview and understanding of what this test is all about, and the concepts and applications. So for example, if you hear the term, I'm going to change this slide, binary regression, you know exactly what is going on, what the researcher is doing, etc. Versus if you hear the term multiple linear regression, you know what the reader is talking about. And so what we try to do is just make sure you get a very good, broad understanding, of the different types of statistical tests and when they can be conducted. Now, for example, if you're doing coursework, you may have an application assignment where you have to do a binomial regression test. More than likely, you're going to have a data set. Well, when you open that data set up, how do you know what variables to select? How do you know what scales of measurement are to be used? And so this is where we're trying to get at that broad understanding, so that you can proceed further in conducting the test. And then perhaps more important, understanding the output, okay? And again, I'll provide you with some additional resources that you can use in your quantitative journey. And again, I'm going to lead you to a survey, an anonymous voluntary survey that I really would appreciate you take a few moments to complete for me. So what are we going to do here? I'm going to talk briefly about the scales of measurement. Again, any of those that have sat in on these sessions before know I always start out these statistical test sessions with the scales of measurement. It's so critical to understanding and moving forward. Then we'll jump right into the binomial logistics regression test. Why do we use it? When do we use it? Under what conditions? Why would I use this test versus, say, a multiple regression test? We will briefly discuss the data assumptions. I'm going to mention what they are, discuss assumptions. We're not going to go into detail on how to test them and assess them, but I will give you a resource of a previous binary logistics regression session that I did, and that particular session went in detail on the data assumptions, okay? So you will still have everything that you would need to understand, the binary logistics regression test. We'll look in SPSS and go through the procedures. Again, which I'm not really focused on. What I'm going to really be focusing on is the output and interpreting what it is that we have just produced. But then more so take it one final step further and then take that output and put it into an APA compliant results write-up. For example, something that may be for an application assignment, or even perhaps, a chapter 4 or a results section, of a doctoral dissertation or final capstone project, whatever that may be. I will point you to some additional resources. We'll summarize, and again, we'll take a quick look at that survey. So let's go ahead and get into binary or binomial logistic regression. Now, before we get into logistic regression, I'm just going to briefly speak about the scales of measurement of the data. And we know that we have 4 scales of measurement: nominal, ordinal, interval, and ratio. What we are going to be talking about here is a dichotomous variable, or basically a nominal dependent variable, meaning that dependent variable is not numerical. There's no score such as a Likert scale or a score on a psychological assessment or anything like that. It's a response such as yes or no, a dichotomous response. And you are trying to predict that dichotomous response versus, say, with multiple regression, you're trying to predict a numerical number. Okay, does that make sense to everyone? So really, under the conditions, you know that if you are not selecting that dependent variable as a dichotomous variable for this test, that your output's going to be wrong. Okay? So that's why it's important to understand the scales of measurement. And you're trying to predict that dichotomous variable from the values of, one or either 2 or more predictor variables. Okay? And those variables can be any scale of measurement. Now, examples of these dichotomous dependent variables can be yes or no, a high or low response, or male or female, positive, negative, etc. And you're trying to predict that. Let's take an example of trying to predict, a disease, if someone has diabetes or not. And the respondents will say yes, they do, or no, they don't. But then you'll have a lot of other data that you can use to predict that yes-no response. Who's more likely to have said yes, they have diabetes? Who's more likely to say no, they don't have diabetes? So that's the conditions and the understanding. Is that everybody okay with that? Everybody understand that conceptual difference between a binary logistics regression and a multiple regression? Everybody okay? Is there anyone out here conducting a dissertation or something and planning on predicting a dichotomous dependent variable? If so, what might that variable be? If anyone is saying yes, what might that variable be? Okay, I'll give you a minute to think on that. You may not have that all figured out at this point, but yes, if it is a dichotomous outcome variable and you're trying to predict that outcome in 1 or 2 categories, binomial logistic regression is probably the test for you. Now, okay, Regina has typed in there. Give me just a second. Diagnosis of pancreatic cancer. Okay, all righty. And more than likely, you're looking to see if that response is if that person had a diagnosis being yes or no diagnosis being no, something of that nature. So that's dichotomous diagnosis of postpartum depression. Yes, But again, make sure you know that response is dichotomous. When you look in that data set, exactly, Modesta, access to healthcare, yes or no? Exactly. And those are the types of variables that when you look into the data set that you're looking for, and I'll even give you a little bit more specific information on that. But those all seem to be very applicable. Now, let's just talk about alignment. And this is more along the lines of research, but if you were conducting a study and you were trying to predict something, of course, you have that final statement, that gap in the literature that comes up. And, after your abbreviated literature review, and then you're going to say something like, you've looked at a lot of literature examining relationships between certain things, because that's what you're doing in the literature review. But then you're going to say there is a gap, something you did not see in that literature, and that's going to become, the focus of your research, that gap. And that gap can be so specific that it really gives us a lot of information, such as your method, your design, a lot of things, even the variables can be, included. But basically, this researcher is saying that they looked at a lot of literature on cigarette smoking. Okay, cigarette use. Excuse me. And what they did not find where some relationship was extended. So in other words, they knew the relationship between demographic factors such as age and gender, okay? And how they are related to, say, age. But this researcher decides to take it a bit further, but saying that, I did not see, where other predictors such as peer, and this ATOD stands for peer's attitude toward other drug use or something like that. And then weight, an individual's weight. And because this researcher, I guess, assumes that, an individual's weight, perhaps if they're overweight or something or underweight, they may smoke more. I don't know. But as you can see, the predictors of, and so we got 8-day cigarette use. And in this case, this data set has asked the individuals, have they smoked a cigarette within the last 8 days? That is what we're trying to predict. And in that data set, there will be obviously yes or no response. That individual smoked within the last 8 days or they didn't. And we're going to try to look at this model here. And when I say, gender, age, et cetera, these predictors are the models. So basically the purpose is to examine that relationship between gender, age, peer, weight, again, which will be those predictor variables, okay? Predictors, okay? And then we have the dependent variable, 8-day cigarette use, okay? We just simply turn that into a question. What is the relationship between, and we just restate what we have. And you see how everything is flowing from the gap? Let me draw that. How everything is flowing from the gap to the purpose, to the question, and nothing, and even to the hypotheses, and nothing is altered. There has been no additional variables added somewhere that perhaps weren't in the gap. That's alignment, to making sure that we're staying on track and every component is saying the same thing, okay? Now, there's different ways to present that, okay? But I want you to understand the concept, okay? If all of a sudden I come to this question and I see something about, while controlling for something, I'm going to say, where does that control piece come from? Why didn't you identify in the gap that something needed to be controlled? Do you understand that? That's what you're trying to do. Once you identify that dependent variable and those other variables, which are the predictors or theoretical understandings, you don't go outside of that scope. You remain in that scope. And really, you'll see once you do this, things become easier. You've really refined what you're doing, and you don't go outside of that scope, even in your literature review, okay? Okay, so now, let's talk about this regression, okay? And we're going to talk about 7 data assumptions, okay? Now, logistics regression is what we call a parametric test. And you've heard the term parametric and probably non-parametric. Simply, a parametric test is a test that comes with data assumptions. In other words, these are conditions that should be met, excuse me, with the data. If you're familiar with regression, you probably heard of, the assumptions of linearity and normality. Data needs to be normal and linear, no existence of outliers. That's what we're talking about when we talk about, the assumptions surrounding a parametric test. And there are 7 assumptions associated with logistics regression. And only 3 of those you really are focused with on SPSS. And I'll talk about that a little bit later, okay? But the point here is that when you conduct this parametric test, if you have not done anything regarding assumptions, you're heading in the wrong direction. You assess assumptions before you run the test, okay? And we'll talk about that a little bit more. But remember, that's the main concept. Now, let's talk about these assumptions just briefly. What are they? An assumption is a characteristic about the data that you have collected or the data sitting in your data set that if it's violated, it changes conclusions, interpretation. We don't really trust the outputs. We don't really have any reliability of the data. We just don't know. And so what are these characteristics, okay? But first of all, in real life data, these assumptions will be violated. Many students, conducting research will say, oh my gosh, my assumptions are violated. Do I have to go back and recollect data? No, you're not going to recollect data, until you get that ideal data set, because that never happens. It won't happen. But you'll have to tell the reader, about those assumptions. What are they? How are they, to be interpreted? What impact do they have on your data? That's your task, okay, with assumptions, okay? Now, so what happens in a well-written proposal, you will tell me what these assumptions are. Identify, excuse me, that's an error. Assess them. You're going to have to do something in SPSS. Now, then, if any of them are violated, you also have to do something, take appropriate actions, okay? You do not want to miss this step. Now, again, same thing. Assess them, identify the results of the test. If you assess them, tell me what you did. For example, if you had outliers, tell me what you did. Perhaps you may exclude those outliers out of the data set. Simple as that. I don't know. And then you would run the regression analysis. Okay, does that make sense to everybody from a very broad perspective? And you can understand we can't go in detail, in depth with all of these assumptions, but you need to test them. And have you heard of assumptions such as things like linearity, normality, et cetera? Those are the kinds of things that we're talking about. And a lot of parametric tests, must meet those assumptions. Well, not necessarily must meet those, but we have to assess those, okay? Now, these are the ones that we have to be controlled with, okay? That dependent variable, of course, needs to be dichotomous, right? Yes or no. If it is not, we cannot run this test. Simple as that. Or if you run it, it's going to be wrong, not make any sense. Now, the predictor variables, or the independent variables. The beauty of this test is that they can be either continuous, meaning interval or ratio, numerical. They can be ordinal, like that Likert scale data, or they can even be categorical. It doesn't matter, okay? We have something called independence of observations. Don't worry about that, especially if you're using a data set for an assignment. You don't worry about that. And then, of course, there should be a minimum sample size for any quantitative test. Now, when you conduct your research, you have to calculate that sample size prior to you conducting your study, because you need to know how many people or how many data records do I need to use, before I analyze my data. Now, these are things that you have to think about in the design. But now, when we get into SPSS, there's some things we have to do. We need to check that data set to make sure we have no significant outlier or influential cases. We have something called no multicollinearity, and that just simply means that none of the predictor variables, okay, we're not talking dependent variable, but let's say we have 4 predictor variables. We do not want any of those predictor variables to be highly correlated with each other, okay? They should not be highly correlated with each other. If it is, then that's an existence of something called multicollinearity, and that just have negative implications for statistical outputs, okay? And usually, it's a very high threshold, something that needs to be greater than 0.9. A correlation coefficient is greater than 0.9. We know that it can be a correlation coefficient can't be any higher than 1.0. So it really needs to be very high. But anyway, please keep these things in mind, okay? and then a linear relationship between any of your numerical independent variables and the dependent variable with something called the logic transformation. So don't worry yourself about that. But basically, outliers, no predictors highly correlated, and a linear relationship. Those are the things we're concerned with. And in binary logistics regression, if any of these things are severely violated, it really impacts our results. Basically, we have no idea of what that true relationship is, if that makes sense. So basically, things are meaningless, worthless. So that's why it's so important that we have to address these. Does that make sense? Okay, I assume that does, hopefully. Now, one of the things that I'm going to do here, when you get this presentation, there are going to be about 6 or 7 slides that will come after this slide here. I have them hidden now. These are the ones we don't want to go in depth in. So unhide those, and you will have even the slides for how to assess the assumptions, okay? But now, let's talk about SPSS. So first of all, we have understood it's important to understand conceptually what we're doing. How did we get to asking this research question? Why is it important? We found that gap. We took that gap and said, okay, now our purpose is to fill that gap. And we fill that gap by asking this specific question. Remembering everything is aligned. But now, what I want to do is, let's go now and look into an SPSS data file, okay? Now, I have a data file here, and we're just going to look at this for a second, just to kind of familiarize ourselves with what we're looking at. I'm going to explain a few things here, okay? Now, first of all, as you can see, excuse me, I'm going to put something here. Give me a second. As you can see, if you can see where my cursor is down at the bottom of the screen, I'm hovering over some views. And the first thing I'm going to do is I'm clicking on the variable view. Now, this view will not show you any data at all, okay, what the responses were, but it will show you how the data file is set up, okay? Now, let's look at this 8-day cigarette use. Here's that dependent variable, okay? But let's look at that. You see in the values column here, you see that it's been coded that 0 means no cigarette smoked, 1 equals cigarette smoke. You see that variable is dichotomous, and the 2 responses are in the data set. They are in the data set. Now, SPSS knows now how to go in and do its thing, its calculation, and look at zeros and ones and do whatever it does. Does that make sense? What I'm trying to do is to show you that alignment between even what you're writing in your proposal, even the research question you're writing, when you're telling me about the scales of measurement, you really are also talking about what's going to be in SPSS, okay? Does that make sense to everybody? Fantastic. These are very important connections here to make, okay? More so than just, hey, run this test and give me some results. I want you to really understand what you're doing and how this is set up, and that correlation between what you're writing and what you are doing. Remember alignment. Nothing is different. Now, gender. Excuse me, let me get out of here. Okay. Now let's look at gender. And again, same thing. You see that? This is coded. They have coded males as a 0, females as a 1, okay? But this is a predictor variable, but remember we said that it can be any scale of measurement. So we have a dichotomous or nominal scale of measurement predictor variable here. And we can do that. Now let's go to age. Now age, we're using this just as a number, 13, 14, 15. Notice there's no values here. We don't need that, okay? We're just going to type in the number. And then here's that peer pressure variable. Same thing. It's going to be a number. And weight. Weight is categorical. You see that? And we know that because when we look into the variables, the variables box, you see that? We have 3 categories of weight. We coded 1 if someone is underweight, 2 if they're average weight, 3 if they're overweight. Does everybody see that? So the other thing that I want to show you is that look at how those variables are listed in the measure column. You see, let's look at weight. We said it's nominal, 3 categories. Notice we also have to make that selection here in this column. You see, we have the scale, the ordinal, and the nominal. So for each variable, we select a specific scale of measurement. That's why I was trying to show you that it's so important. So if you were putting data in yourself, you would have to put this scale of measurement in there, and you need to know what it is. So for example, we know that's nominal, but if it was something different, I would put scale. You see that? Now it's changed to scale, but it would be wrong because we have listed it as a nominal variable. You see? So let's go back and get weight now, and let's put that back as nominal. So again, you're just going to click in the measure column, okay? That's a very important column for you to understand. Let's say you're writing a dissertation, every single one of your variables is going to have one of these 4 scales of measurement. You're going to need to know what it is and select it in SPSS, okay? Does that make sense? Okay, great. I don't want to go too far without you really understanding the behind the scene things. I think it really helps you see a clearer picture. Now, okay, so now let's look at the data view. Oh, here we go. Good data. Okay, here we go. Now what you see here, individual number 1, they smoked cigarettes. It was a male. He was 21. And these were the peer pressure scores, the weight. Does everybody see that? How the data now is aligning with the variable view, how the data was set up. Does everybody see that? Great. Now I'm going to give you another tip here. Now notice when we were behind the scenes in the variable view, 8-day cigarette use was coded. It was 0s and 1s, right? So why do I see smoked cigarettes and no cigarette smoke? Now, where I'm at here, does everybody see where my cursor is up here in the alphanumeric, the A1, the red A and the 1? Now, watch what happens when I click that. Look in the smoked cigarettes column. Look what happens. Do you see that? How it changed it from the alpha to the numeric, vice versa? Just a little tip. You don't have to go back to the variable view to see, okay, how did I code, smoke? Does everybody understand what I'm doing here? You don't have to go back to the variable view like I'm doing here, go to cigarettes, go over here to my values to see how I did it. I don't have to do that, okay? When I'm in my data view, I can just simply hit my alphanumeric button, okay? Just a little tip to help you, save some time. Do we have a good understanding of this data set here and kind of the very basics? Okay, good. Now, when we run the regression, it's a process up here, your main menus, and everything is going to be in the Analyze menu. So I click on Analyze, and you're going to get a whole bunch of selections that you can choose from drop down. But now here you see I'm at regression. Does everybody see where I'm at? I don't want to go too far. Does everybody see where I'm at regression? Now, we have a host of regression models. I'm doing the binary logistic. Okay, you see that? Everybody see where I'm at? I click. Here's my dialog box. excuse me, this is where you put your variables in. So let me just take these out of here and just show you the process of putting them in. So you've got your data set. You say this is the binary regression you're going to run. Well, we know the dependent variable has to go in the dependent box. That's the 8-day use of cigarettes. Just click, put it in there. We have 4 predictors. Sex, we put it in here, right? Now, we had age, right? We just simply put it in. We had the school peer score, and we had the weight. Now, notice that sex and weight have the word CAT after that. Does everybody see that? Does everybody see where sex and weight have the word CAT after that? That's letting you know that that is a categorical predictor. Okay, a categorical predictor. Now, when you have a categorical predictor, you must click on the categorical button. Does everybody see that? And what you're going to get is you can see the sex and the weight variables. Okay? Now, does everybody see after the sex and the weight, you see the words indicator first, indicator first? Does everybody see that?
Yes.
Okay. Come down here to the reference category. Do you see reference category? It says first and last. And I have selected first. Now, what does this mean? This is very important to our interpretation of the output. Now, what we're saying here is that when you have a categorical variable, and I'm going to go with, say, 3 categories, that weight one, that's a good example. Underweight, medium weight, and overweight. We have to compare those weights to each other. That's the way we will interpret the output. If weight is a significant predictor, what we have to do is say which one is the reference category. Which one will I be comparing the other 2 against? Does everybody see that? Understand that? Now, what do we mean by that? We said first, let's do something. Let's go back into the variable view. And that was the weight variable. Here are I'm going to move this to the center of the screen. Where did it go? Well, weight. Now, remember when we had set up the value labels? We coded this as a 1, 2, and 3. Remember that? Which one is listed first? The underweight, right? Remember we had something in that other dialog box also called last we could have selected? That would have been overweight. So what we're saying, because we selected first, is that if weight is a significant predictor, we're going to get some coefficients that we have to compare. But what we're going to be doing is comparing the average weight to the underweight, and we're going to be comparing the overweight to the underweight. Do you see that? Because the underweight is the reference group, the reference category. How do the average weight differ from underweight, and how does the overweight differ from underweight? Does that make sense? Fantastic. These are very important concepts to understand. Now, had we changed it to last, overweight would be the reference category. Okay? So we have that choice. You have to determine which one you're going to make as the reference category. Okay? Okay, so now we were into the analyze, we were in regression, binary logistic, and remember, we got the dependent in here. We had categorical variables, and it will tell us that it's categorical. So the data file, remember, has to be set up correctly. That's why the scales of measurement, again, is so important to understand and to get the data file correct, okay? Now, at this point, I'm just going to the options and let me see. And, you can click on some plots here, the classification plot. Make sure you click on the Homer and Lemshow goodness of fit, and I'll explain that, okay? And you can just kind of follow what you see here. You hit continue, and there you are. You hit okay, and what you get are the results of your binary logistic regression analysis. And now we're going to examine this, okay? A little bit more in depth. So that here within the next 15 minutes, we are going to understand exactly what all of this means and know how to write this up in an APA results write-up, okay? Now, first of all, you're not going to need all of this output. It won't be necessary. So when you go back to the presentation, okay, you'll see the major pieces here that are of concern. Okay? Now, as you can see, I just had the question up here again. But now, we know that this model, and when I say model, I'm talking about predictor variables, gender, age, pressure, and weight. I know now that these variables are significant predictors of if one responded yes or no to smoking in the last 8 days. How do I know that? I'm going to look at the omnibus test of model coefficients, okay? And for the model, it's going to be less than 0.05. Does everybody see that? Okay. Now, again, let me just go back to the SPSS and show you where that was. You see right here, the omnibus test of model coefficients? There it is, right there. Significant result. But now, excuse me. But now, the other important piece, let me skip that, and I'm going to go to the next piece here, and I'll come back to that. Another important piece of evaluating your model, and perhaps the most reliable test of how well the model fits, is something called the Homer, Homser, and Lemshow test. It's going to be in your SPSS output. I want you to be able to look at that SIG column. Now, this is the difference here. This SIG is not significant. It's greater than 0.05. That's what we want. We do not want it to be statistically significantly different from a good fit. Do you see what I'm saying? We don't want it significantly different from a good fit. So we don't want this less than 0.05. Does everybody see that? And you see what I'm saying here? Poor fit would be indicated if the P was less than 0.05. So this is one time where the 0.05 you interpret and evaluate differently, okay? Now, but we noticed that omnibus test, omnibus in statistics means overall test. It didn't tell us anything about the individual predictors, did it? That's what we want to know. Now, remember we had the 4 variables: sex, the age, the school peer pressure, and the weight. Now, notice, remember when we had the first and the last, when we talked about that, in setting up SPSS and telling it that it was a categorical variable? Well, in this data set, you'll notice that there's no coefficients here, no beta here, nothing here. Because what this is for the reference, the overall variable. Now, we know here that this variable is not a significant predictor, okay? Does everybody see that? We know it's not a significant predictor. But one of the things that we are concerned with and understanding, as we saw last night with multiple regression, is the slope. Okay? Now, weight, we had a reference group. And you see here, your reference group here, I say was the normal group. Okay? And we had the underweight group, and we had the overweight group. Now, again, you select what group you're on, but let's just say this was the underweight, in the data set, right? Under. What we're saying here is that for a 1 unit change, okay, for a 1 unit change in weight, and now what we're taking here is this weight here. This was the second one in the list. So this would have been the normal, I guess. So what we're saying is that slope differs by this much from whatever this slope would have been. So in other words, that logic odd would go down. But you're not really concerned with logic odds, okay, like we did last night in multiple regression. But what I want you to see here is that you can see that you have the two categories that you are comparing to the reference group. Does everybody see that? And how that related to how we had to set up the SPSS data file. Does everybody see that? Does it make sense? Okay, let me erase that and let's go over that again. Remember in SPSS, we had to set it up where we had either first or last for the categorical variable. Basically, what we're saying here is that this was whatever category we set this up as the first one. And we're comparing this one to that one, and we're comparing this one to that one. Okay? Again, that's what that means. Now, really what's important, remember now, in multiple regression, we can use this. But here we're talking about something called logic odds, and we don't want to talk about that when we just reported the results. That's something a statistician is concerned with. We're doing applied statistics here. What's important is something called EXPB, or basically, has anyone heard of the term odds ratios? Odds ratios. Okay, fantastic. This we can understand. Age at baseline. What we're saying is that, again, for a 1 unit increase in age, that individual was 1.167 times more likely to have reported smoking cigarettes. Does everybody see that? Let me clear this up and let me do it again. The important thing to interpret would be your odds ratios. Okay? Remember, for a 1 unit increase, and no matter what we're looking at, for these numerical variables, remember numerical, because these are categorical, we're interpreting these differently. That's the point I'm trying to make. So as you can see, it all goes back to what? The scales of measurement and understanding those. Okay? Now, for a 1 unit increase in age, okay, +1, that individual or that age group is 1.16 times more likely to have reported smoking a cigarette. And that particular variable is statistically significant. Does everybody see that? Now, in this model, none of the other predictors provided any significant contribution to the prediction. Does everybody see that?
Yes.
Fantastic. Now, let's take this a step further. Now you're asked to put this into words, into an APA results write-up. Present your findings. Fantastic, Samir. Yes, they are greater than 0.05, and that's the threshold. Remember that one case where we're not looking at less than is for that Homer and Leemshill test. Okay? Now, let's take a look at this. Now, this looks a little crazy, but I have a Word document for you also. But I wanted to put the output here so we can kind of look at it and compare it to the narrative. Okay. Now, basically, here's some information. The sample size was 388. That tells you that's what was included in analysis. You know how many missing cases, etc. Things like that. Remember, here's something called the omnibus test of model coefficients. The overall test that says that these variables collectively predict 8-day cigarette use. The model was significant in this particular case, okay? So what we're going to say here is that, we did binary logistic regression. And again, I'm not going to repeat this, but remember, that's the same question, the same purpose that we had. That shouldn't change. There shouldn't be a new variable that pops up here again, or a new variable sitting up here, in the output. That should not happen, okay? Now, remember, you can go to the other, and I will point you to the link to the other logistics regression seminar that goes step-by-step of assessing the assumptions. But what we did here, we had to say the results of the preliminary analyses, again, which are the assumptions, indicated, remember, no outliers, that was an assumption. Remember, none of the predictors were highly correlated, no multicollinearity, and linearity was not violated. This is just for example purposes, okay? Now, and then you would have a table perhaps that would have something in there that reflected that. Now, the important piece, reporting what we call the statistical notation. This has to be in your abstract for a final dissertation. It needs to align with what's in the study. But let's look at that. The results were significant. We know they were significant because the omnibus test told us that. But notice we have an x squared. This is just the symbol here for a chi-square test, okay? That's the symbol. Remember, from like a multiple regression, that would be an F statistic, okay? But the chi-square test, the statistic, is what's created for a logistics regression test. Now, anyone want to take a stab at the 5? What does that tell me? Anyone on the call last night from multiple regression?
Wants to take a stand at what, please? A stab at what?
Excuse me?
The question, please.
That's the number of variables.
Yes, the number of variables. Now, remember, last night, this was the number of predictive variables in the model. But now we have 5 here. That is the total number of variables. Remember, 1, 2, 3. This is the 4th variable, weight, plus we count the dependent variable. Does everybody see that? We count the dependent variable. So now from looking at this, I know a chi-square or logistic regression was done. I know how many variables are in the model. How many predictors were there just by me looking at that 5? How many predictors? 4, exactly. You see how so much information now is coming to me just by looking at this? How many records were examined? 388. That comes right from your case processing summary. Everybody see that? Then the chi-squared value was 17.041. And I tried to color code this for you so you can match the color codes, okay? 17.041. And then we report the p-value, which was 0.004. Everybody see that? We good so far? Now, when we look at a logistics regression study, we are now able to critically analyze that study. We look at the literature and we say this, but this is the important piece, because in a dissertation, you're going to have to compare your findings to what you should have talked about and put in your study. When you're talking about the results of what you are reading, your literature review, this helps you understand that. This helps you understand the number of variables, the sample size. Suppose that N was 8. You would automatically say, whoa, 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 that's a small sample size. Whoa, this study probably doesn't even need to be looked at. Do you understand how you're getting information now to help you make decisions and understand the research that you're reading, other than just the narrative, problem statement, purpose, and literature review? Is this helping you understand why all that's there and how it connects to what you have done in the literature review? And then we just make a narrative statement, and that means that this model was able to distinguish between those who reported they did and did not smoke cigarettes within the last 8 days. Does everybody see that? All you're doing is getting your output, transposing it into something like this, but more so understanding what goes where. Okay, now, in many cases, that's all, that's good. But we're going to take it a step further. Now, remember, for multiple linear regression, and really with any parametric statistical test, the p-value, even though we think it's the most important thing, it really isn't. Some of the most important things are the measures of effect, the effect size. Now, we have R-squares in binary logistics regression, but they call them pseudo R-squares. But you can see here we have something called a Cox-and-Snell R-square and the Nagel-Kirky R-square. It reports two values of, this R-square. Now remember, from our math days, we turn a decimal into a percentage by moving it 2 places to the right. So basically about 4.3% to 6.2% of the variance in the dependent variable is explained by this model. And now we just put that in here. The model explained between 4%, and I just rounded, and I made sure that I said that the Cox-and-Snell estimate, and 6%, the Nagel-Kirky estimate of the variance in smoking status, and correctly classified 73.2% of the cases right from the classification table. Then now, I'm not an expert in the, epidemiology field, because a lot of this stuff, deals with, specificity and sensitivity. For example, in the days of the beginning of the, coronavirus, a lot of the initial tests were coming out, and, the false positives and the false negatives and all those things. Well, the positivity rate, the positive positives of that sensitivity, you can see the sensitivity was outstanding. And if you have a high sensitivity, you should have a low specificity, which are the false negatives. You see, so this kind of gives you a lot of helpful information. If we were trying to predict, how well, say, one of those tests would work, this is important information for us. We don't want something at 28% sensitivity, only predicts correctly, so this is important information to understand that should go into the narrative. Now, this really can also go into a very good discussion, because you're an expert perhaps in that topic, in your discussion section of your dissertation, talking about sensitivity and specificity, what the impacts are, implications for your research. You see? So this really leads you to that next section. Does everybody see what I'm saying? It really leads you to the next section of, of a dissertation. It sets up the stage for what you talk about next. Now, then, what we do here, you say age, remember, and we looked in the model, we knew that age was the only significant predictor, okay? And reported that odds ratio of 1.167, and there it is, age. indicated that a 1 unit increase in age resulted in respondents being 1.16 times more likely to report that they smoke. You know, some studies you may get, you know, these odds ratios say 9.5 or 25 point something. Depending on what you're researching, that could be significant, the odds ratio. But we do know that as one ages, they're more than likely to report they smoke within the last 8 days. That's what this is telling us. Does everybody see that? And you would just make these implications appropriately for whatever your variables are and whatever the context of your research is. Okay? Now, the next thing that I want to do, but are we good? Does this make a little bit more sense here than perhaps it did 30 minutes ago? Okay? Are we starting to ease that anxiety? Remember, you're not going to be an expert in this, and you don't need to be, but have we eased that anxiety? Perhaps if you're taking a quantitative course and you have to run this test, has that anxiety been lowered a bit? If you're perhaps, you know, contemplating doing this for a dissertation, is that anxiety lowered a bit? Do you kind of have a better understanding of what you're doing? I hope so. Now, the next thing is resources. I'm going to point out, first of all, the ORDS, the Office of Research and Doctoral Services first, where a host of quantitative seminars are located. And I'll talk about that in a second. The scales of measurement. You know what I feel about the importance of that. Layered Statistics, an excellent website that talks about binomial logistics regression. That seminar that I did that goes in depth with me assessing the assumptions, et cetera, will be here in this binomial logistics regression link. Does everybody see that? So that portion that we missed that would have taken us into 2 to 3 hours, we now know where to get to it at, okay? Is everybody good? Okay, thank you for that. Now, let's take a look out here towards. The Office of Research and Doctoral Services, this is where I work. And as you can see here, this is a link to upcoming sessions. This was a session last night that I did. And I've got to get that link taken out of there. And it's going to be put down here in the on-demand quantitative seminar recordings. So as you can see, there are a host of webinars, just like we're doing here tonight, from bivariate regression, intermediate SPSS, if you want to, you know, beef your skills up. All of these different tests, quantitative secondary data analysis, really understanding what is statistical significance, effect size, confidence intervals, all of these very critical concepts that you will be writing about and talking about, you know, in a dissertation, okay? And as you can see, the list goes on and on and on. There's their scales of measurement, okay? Now, so I'm going to take the link and bookmark it and put it into the chat, but you have it in the slides when I put the slides in there. But again, as you can see, for example, Tuesday of next week, I'll be doing the chi-square test of association, okay? So if that interests you, just register and I'll see you next Tuesday night, okay? And this list is where you want to go, you know, with a lot to get a lot of the training that you need. Now I'm going to take that link and I'm going to put that in the chat, okay? Okay, so everyone should see now the bottom of the chat, there should be the link. But again, remember, it's going to also be on the slides, okay? Now, the next thing, I believe, was something, and that scales of measurement is going to be in there. Now, another very helpful website that I always refer individuals to is Layered Statistics, okay? I think it's a very good site. Now, as you can see, here's going to take you right to binomial logistics regression. And they have every test under the sun in here, okay? And as you can see, we talked about regression. You see, it talks about an observation falling into one of two categories of a dichotomous dependent variable. The assumptions that we talked about, okay? Here you go. How to set it up in SPSS. Remember, we looked inside a data set to understand it. How to run it. Remember, analyze, regression, binary. Remember, dependent variable go here. Excuse me, predictors here. Remember, in this case, they're not showing any categorical variables, okay? So they would move on. But let's just say, for example, gender was in here. Well, gender is in here. So that ideally should have been highlighted. Yeah, they did. See, gender is highlighted as an indicator variable, categorical. And you see here, reference category is the last one, not the first one. They use the last. And this will be very helpful. And you'll see it'll kind of align with what we've done, how to look at the output, how to interpret the output. So let's look at this for an example. Can you tell me what were significant predictors in this model here?
We need the
Of course, age is one. Is there another one? Or is it just age?
And gender.
Fantastic. You see age and gender. Now, what can you tell me? What can you tell me about the gender variable? Now, let me put it this way. Let's assume that I coded male as a 0 and female is a 1. Male 0, I'm going to put that in the chat. Male 0. Male equals 0. Okay. Now, what does this mean here? If you were doing this at your oral defense for your dissertation, and I say, hey,
so when the
tell
gender
me, with that gender variable, with that odds ratio, what does that mean in English terms? What would you say?
So when the gender basically changes by 1 unit, then the odd ratio by 7 times it will change.
Say that again, please.
So when the gender that changes by 1, say unit, then the change will be 7 times. They're in the
Okay.
factor of
Now,
7.
but basically, you can get even a little bit more specific. You can tell me that the female,
Seven times
remember,
more.
0 to 1, the female is 7 times more likely.
More likely, yeah.
Yes, that's what I want you to understand. That's what it is. So that's why it's important to know how it's coded in SPSS. So you know what's the 0, what's the 1. So if it was reversed, we would say that the males were 7 times more likely to report smoking within the last 8 days. So we know that really, now let's just say we are counselors, in a school, and smoking is a problem that we're trying to deal with, and we have a small budget. And who would we focus on? The females, probably. You see what I'm saying? Because those are the ones 7 times more highly likely to do it. This is how we make decisions from data. Does that make sense, what I just said there?
Yes.
no.
Yes. Okay, great. So this is what we're saying here when we look at this. Now, the thing is here, these are just the confidence intervals, but again, it's for the odds ratios, which is right here. 95% confidence intervals are very important to understand also. Let me explain. What that means is that, when you ask someone what that means, they're going to say, oh, I'm 95% sure of this or that. No, that's not what it means. What it means is that, let's just say that we were to conduct this study 100 times. You have a data set, and each time you go in that data set and you sample from that data set 100 times, and you run the binary logistics regression test. What you are saying is that 95 out of 100 times, we are sure that the lowest that the odds ratio can be is 1.030. As you can see, it's a little bit lower than that. And the highest that it can be is 1.151. Because we're never 100% sure. But we're saying now we are 95% sure. Now, suppose, those confidence intervals were wide. What does that mean to the research? I don't know. Confidence intervals can give explanations also. Okay. Now, let me show you something here. Look at that. That's very disturbing to me. Why? I don't know if this true exponent B it can be anywhere between 1 and 36. You see that? It could be anywhere in between there. First, they have 95% certainty. So again, it's just interpretations. Each study, this will have a different meaning depending on the context of the study. One has to be engulfed in the research. I don't know, but I just want you to start understanding, what this stuff means, and then you'll be able to make sense of it, out of your particular research. But does this make sense to everybody here? This is exactly what we looked at, in the PowerPoint and when we went into SPSS. So this website, again, which is in the presentation, I'm going to take right now and I'm going to copy. And now that should be in the chat. Does everybody see that?
Yeah, please, I just have a quick question
Yes.
about the variables equation, the table we just saw about the female and male thing, the gender, the number one that's in bracket. What does that represent?
I don't know. I mean,
Male?
what it's saying is, see, I'd have to look into the data set to see what they mean by that. Okay, this is just showing me output here. I'd have to look into the data set to see exactly, what they're meaning by that. That's a good question, but where's that at? Let me see here. Yeah, see, I don't have the data set to know, what's the reference group. You see what I'm saying? I don't know. So, that would either be a 0 or 1 or something. I don't know what that is, but, it's letting you know, number one, of course, it is categorical, and that, it's another variable there, one more that they're comparing that against. Remember when we looked at the other one with the weight, we had the, the main line here, but then we had two others under that, and it had the 1 and the 2, and it was showing that it's comparing that against. So you would have to look into the data set to really know what's the lowest coded one, 0, and what's the highest coded one to be able to talk about, males and females. Does that make sense?
Dr. Taylor?
Yes.
I have one question. With regards to that very big difference between the lower and upper interval of gender, how do we say that in chapter 5? How do we explain that? Or is there like
I could not tell you that because that's the context of your research. Again, this is the confidence interval. Now, explaining the confidence intervals, you would be explaining confidence intervals, what they are in your chapter 3 when you're talking about how you're going to interpret the data. But what a 95% confidence interval, the concept of that is that this has nothing to do with really what you've done. What this says is basically the SPSS has went into the data file and resampled like, how many times, and 95% of however many tests, say 100, the lowest value was here and the highest value was here. Now, what that means in the terms of your research and how you talk about that, I could not tell you. That's very research specific. It's in one particular topic that may not be significant. I don't know. This is where the researcher now makes sense of these types of things. Some things we're just going to report, the statistical notation. Now, what does all that mean? I don't know. Because this is very context specific.
Okay, thank you.
It could, you could, I don't know. But that's the concept of that, okay?
So there's no particular APA style of saying it. It's really up to
we're going to get there. We're going to get there. Okay, I see what so you're asking for APA. Okay, all right, I see what you're saying. You could just simply add that into the table, into your narrative, and we're going to get there. Okay, I see what you're saying. Okay, now, so And what I'm going to do now is take you to a Word document that I'm going to put into the chat. This is an exemplar. Okay. Here we're talking about, binary regression. Okay. I have a forward here, telling you again, this is just a play it safe example. Your faculty, your program may require different things, blah, blah, blah. Kind of like my disclaimer. This is just simply the example we went over, that alignment and the results that were presented. Now, as you'll notice here, I have a regression summary table, and there are the 95% odds ratios right there. Okay? That's where you would show them at. So you don't have to say anything about that for the 95%. You say table, 2 shows a regression summary, and we know that a regression summary table should include this information, okay? But if someone asks you what is a 95% confidence interval, you should be able to talk to what that is. But that's how you report it, because you asked APA, that's how you report it.
Okay.
Okay? Now, let me take that and put that into the chat. So just bear with me. I got a lot of screens open, guys, here trying to get a lot of stuff to you. So please bear with me. Okay. Let me see where I put that. You guys are going to have to look at some New York Giants for a minute there. Okay. Okay, now please check the bottom of the chat and you should see a binary logistic regression Word document. Yes, no? It may take a minute to load. I don't know. Okay, fantastic. Now, before we forget, let me get the PowerPoint presentation in there for you, okay?
Okay.
I'll just save this one to my desktop right quick. Okay, now there should be a binary logistics regression presentation in the chat. So you should have everything. The presentation and the exemplar are the documents there, okay? And I put some links, but again, remember all of those links are still in the PowerPoint presentation, okay? So what we've done here is reviewed the scales of measurement, and you can see how important those are and how critical that is to, examining, and if you're setting up a data file, to make sure that you identify the correct scales of measurement, the categories, et cetera, because that's important to running the test. We went into regression, talking about, again, predicting that dichotomous dependent variable, okay? We know data assumptions are very critical, and you know that there's another seminar that you can look at to get detail in that. We looked at how to run it in SPSS, but again, the Laird Statistics website will show us step by step. Also, the other binomial regression session that I did. You can see how I did that also. And, we looked at the output. We now understand how to look at some of that output, the critical pieces. And I pointed you to some very helpful resources. Now, the only other thing that I would really appreciate is for you to take a few moments when you get a chance to fill out this survey here. And I'm going to copy and I'm going to put it into the chat just to show you. First of all, I'm going to put it into the chat. And then we're just going to go out there real briefly and take a look to see. And it'll take you to something that looks just like this that asks you, some information, which session. So it would be the binomial regression session tonight. And just a few other, Likert scale items. These are ordinal scales of measurement, just for understanding purposes on a scale of 1 to 5. And then your narrative input that really drives what I do for you and how I do it. So really, this is going to help me provide you with future and continued resources here during your quantitative journey at Walden. Other than that, I thank you very kindly for your time, your attention. I hope you have gotten your money's worth out of this session. And I hope perhaps to see some of you, many of you, if not all of you, next Tuesday night for the chi-square test of association. Remember, the resources are out there with a lot of statistical tests and a lot of the concepts that you may come across. Check there first. Make sure there's not something there, or that there is something there that you can use and save yourself a lot of time and more so ease that anxiety. Thank you very much for your time. I'm going to go ahead and leave the classroom open for a minute if anyone needs to get anything else, out of the classroom or chat with each other. But anyway, that's all that